take a look at some of the statistics probability basics. And this model right here is probably what you're very familiar with as far as probability goes. And our probability of some event happening is equal to f over n, where f is the number of ways that you can win whatever your event is, and n is the total number of outcomes that there are. So for example, if we were rolling a dice and I wanted to know what's my probability of rolling a 6, well, if I use this model, there's only one way I can roll a 6 on a dice, and there's 6 sides to a dice, so my probability would be 1 out of 6. If we were using a deck of cards and I wanted to know what's the probability of picking a queen, well, there's 4 queens in a deck. There's 52 cards in a standard deck, so I would have 4 out of 52, which also reduces down to 1 over 13. So this model right here, the f over n, is probably what most of you think about when you start thinking about probability. One thing to keep in mind is that your probability will always be from 0 to 1. And if you have a probability of 0, that's an indication that it is impossible, will not happen. So if I have just a regular 6-sided dice and I say what's the probability of rolling a 7, well, there are 0 ways to roll a 7, and there's 6 options. Well, 0 out of 6 is 0, so it's impossible to roll that 7 on our 6-sided dice. Now, a probability of 1 means it has to happen. It is guaranteed to happen. So if I have that 6-sided dice and I say what's the probability of rolling a number 1 through 6, well, there's 6 ways that can happen, and there's 6 total possibilities. 6 out of 6 gives me a 1, so it's guaranteed that I will roll a number 1 through 6 if I have a 6-sided dice. So your probabilities will always be between 0 and 1. If you're doing a calculation and you end up with a probability of like 1.2, you know something has gone wrong, because that is impossible to have. You cannot have that type of a number. Now, we're going to be using the term event a lot, and what it is it's a collection of outcomes for an experiment. So with the dice, it would be rolling a 1, that is an event. Rolling a 6, that's an event. Rolling an even. So an event is just a way that we describe the things that we're interested in. Our sample space is a collection of all possible outcomes for an experiment. So we have all outcomes here. So our sample space, if we are talking about a deck of cards, is all 52 cards. Now, that doesn't necessarily mean we're interested in picking all 52 cards, but our sample space would be all 52 of them. Okay, a Venn diagram is a visual way to display an event. And if I have a Venn diagram and just want to talk about some event E, I usually start with a rectangle and put a circle inside of it. Now the rectangle out here, this represents my sample space. These are all possible events lie within this rectangle. Now the circle E here, that represents the event that I may be interested in. So E has to be within my sample space, because E is something that is within all my possible outcomes. Now if I have a diagram that looks like this, this is 2 events that we're talking about. So I still have my sample space. It's very important that you always have your sample space. And I have 2 events, A and events B. Let's say that event A is drawing a heart from a deck of cards, and event B is drawing a jack. Well, now if you think about a deck of cards, I have one card that is both of these, so it has to be in both events at the same time. Well, that's where this overlap is. That area right there includes only the jack of hearts for this particular situation. So event A would be all the hearts, event B would be all the jacks, and this piece in between would be the jack of hearts. Now if we're talking about any of these, so if I'm talking about a heart or a jack at the same time, then we're talking about an OR probability. So this would be an example of A or B. Because I could be A and I could be B. Now, keep in mind with statistics, when you have an or probability, it's not one or the other. It can also be both. So this overlapped area is also included in our or probability. Here's another type of diagram. This one, similar type of thing. I have my sample space around the outside. I have my two events, my A and my B. But now this time only the overlap is shaded. Well, this would be an example of A and B, because it doesn't want the things that are out here that are just A. It only wants the items in the overlap where A and B happen at the same time. So if A is still a heart and B is still my Jack of hearts, then A and B would be selecting the Jack of hearts. We have some notation that is going to go along with our Venn diagrams. Okay, the first one is not E, and not E is the complement of E. So if E is my event, not E would actually be all this area out here around the edge. It's not going to be E. We also have A and B. That's that they both occur at the exact same time. That was the last Venn diagram I showed you, where only the overlap is shaded. And then we also have A or B. That means that we either have quality A or we have quality B, or both can occur. And that was the second Venn diagram. Okay, so here's going to be a couple examples. Here's 4 events that I've identified. And first thing I want to look at is, what does it mean to be not B? Well, that's our complement of B, so not B. If we look over here, it says the card is a king. So not B would be that we do not draw a king, so that the card we draw is not a king. If we wanted B or C, now this is an or, so that means the card is a king or the card is a faced card. C and D would be that the card is a face card while at the exact same time the card is black. So those would be our 3 different notations.